Okay, let's talk about graphing quadratic functions. A quadratic function is going to graph to what we call a parabola. So let's go ahead and write that down. So a graph of a quadratic function is a parabola. Let's put a little bit more space there. A graph of a quadratic function is a parabola. And to graph the parabolas, I'll go ahead and write this down too. To graph parabolas, we need to first recognize the features of a parabola. Okay, so what on earth do I mean by features? So features of a parabola is pretty important. So let's take a look at a parabola. So I'm going to bring over, this is a graphing. I just thought that to look at the features of a parabola might be very useful to see a computer image. I thought that would be the most handy way to do it. So there are three features of parabolas that we're concerned with here. The first is the vertex. So this is a vertex right here. It's the vertex okay, sort of. That's kind of an X. Let's rewrite. That looks ugly. Vertex. So it's a vertex because it's the lowest part. Now the vertex is the lowest part if the parabola opens up like this. If the parabola opens down, then the vertex would be the highest part. Basically, the vertex is more or less the center of the parabola, and I'm going to write that down more precisely later on. So then there's another type. There's two other two other features that we're looking for. The first is the y-intercept. So this right here is the y-intercept. Okay, so what on earth is an intercept? Well, have you ever seen movies like maybe naval battles or whatever, when you see that there's one ship sees another ship on radar, and the captain will say to the helmsman, set an intercept course. Well, it's called an intercept course because you're looking to intercept the other ship. What that means is that you're setting a path so that the ships will meet. So what the y-intercept is where the parabola meets the y-axis. So this is the y. Let's write that more to the left. Y-intercept. Okay, that's not the greatest writing, but it's not too bad. So similarly, we also have the xintercepts. Here's one xintercept. Here's another xintercept. The x-intercepts are where the parabola crosses the x-axis. Remember that this is the x-axis, and this is the y-axis. So this right here is the x-intercepts. Don't mean to be going sideways, diagonally like that, so I'm going to try to straighten it out. Okay, so let's go over this again. This is the vertex. This is the lowest part because it's opening up. If this parabola was opening down, the vertex would be the highest part. And the y-intercept is where it crosses the y-axis. and the x-intercepts are where it crosses the x-axis. Now notice something. Our parabolas, in a quadratic form, in a quadratic function, you either have a parabola that opens up or it opens down. So it opens this way. This is one that opens up, or it opens down. In this case, we're not going to be dealing with parabolas that open to the right or open to the left. It's always going to be up or down. What that means is that you will have exactly one y-intercept every single time, and you will have at most 2 x-intercepts, but you could also have just one, or you could have 0. If you have, like, I'm going to try to draw a parabola over here. This is a different parabola. So let's say we have a parabola that opens up like this over here. Okay, this doesn't have any x-intercepts. It's going to have a y-intercept like way over here, but it doesn't have any x-intercepts because it never crosses the x-axis. But it's still going to cross the y-axis, so that's going to have a y-intercept. It's just going to do it. It's going to be like a 1,000 or something. I don't know, but you can see that's going to cross eventually. But the point being is that you can have exactly one. You could have no x-intercepts. You could have exactly one x-intercept. It can touch the x-axis at exactly one place. So like this parabola does. Notice something else. In this case, if you have exactly one x-intercept, it's also going to be the vertex. This is the x-intercept and also the vertex. Okay, so let's go ahead and go on to the algebra behind this. So let's deal with some concise information. Okay, concise info. Now this is going to be something that you're probably going to want to write on your cheat sheet. And first thing we want to do is remember that our parabola is written in the form f of x equals ax squared plus bx plus c. Okay, so here is the concise info. The vertex, and I'm going to explain this in the next section, but right now I just want to go ahead and get it out there, have it written down. The vertex is, hopefully this won't be too small, negative b over 2a. Oh, it's not too small. Negative b over 2a for the x-coordinate, and then f of negative b over 2a for the y-coordinate. So remember that whenever we have a pair, I don't think I used that term in the last video, but you can see that like if you have 2, 3, that's a pair of numbers. And so what we have here, this is also a pair, but it's not written as numbers, obviously. So our x-coordinate, remember this is our x-coordinate, is going to be negative b over 2a. So this would be negative b over 2 times a. Oh, I miswrote that. Sorry, that should be a times x squared plus bx plus c. Okay, I'm glad I caught that. Okay, so this is going to be negative b over 2a. And then this is going to be f of negative b over 2a. So I'm going to explain that in more detail later, but I do want to go ahead and say what this means is once we find out what negative b over 2a is, then we take it and plug it in for x, and then whatever that evaluates as, that's your f of negative b over 2a. So now I'm going to go, like I said, I'm going to do that, I'm going to go into that in more detail, but for now I want to go ahead and finish up the concise info. So, point number 2, to find the y-intercept, set x equals 0, and solve for y. Let's scroll this a little bit to the right. Okay, so to find the y-intercept, set x equals 0 and solve for y. Okay, now I'm going to go ahead and try to let's do it a little bit to the left. Try to explain more or less what that means. So remember that the y-intercept is where it crosses the y-axis. And notice something. At every point, you know, you could pick a point up here. This is going to be, say, 0, 4. That kind of looks like it's going the wrong direction. Here. So that's going to be 0, 4, 7. And this is going to be 0, negative 5, or something like that. So the point that I'm getting at is that when you're on the y-axis, your x is equal to 0. So to find where where the parabola crosses the y-axis, set x equal to 0 in this equation and find out what y is going to be. And again, I'm going to go into that into more detail later. And then we have point number 3. To find the x-intercepts, set y equal to 0, solve for x. So this is the same thing but the other way around. So let's draw that again. Oh, no, not that. That looks terrible. So just find out where to find out where it crosses the x-axis. So you notice that it crosses the x-axis when y is equal to 0. So remove the y and put in 0 for it, which, you know, in this case, remember what I said in the last video. For all intents and purposes, f of x equals ax blah 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 means the same thing as y equals ax squared plus bx plus c. For all intents and purposes, f of x and y are interchangeable, at least in our case. So, to find the x-intercept, set y equal to 0, so just get rid of this, replace it with 0, and then solve for x. And we're going to be doing examples of this later, of course. This concludes the concise info. Now let's go on to a explanation of all this, or the verbose information. Okay, so let's scroll down so we can deal with this. This is going to get pretty long and pretty tedious, but it's good to understand. So whenever we graph a quadratic function, like f of x equals ax squared plus bx plus c. Oh, whoops, line break. We get a parabola. Before I go on, I do want to say that the verbose information is going to be saying the same thing as the concise info, but it's going to be more explanatory. So, whenever we graph a quadratic function like this, we get a parabola. The vertex is the center of the parabola. It is a point in line break. And let's put a little bit more distance between these two paragraphs. So, okay, the vertex is, let's scroll a little bit more to the right. The vertex is in the center. Actually, let's do this. Okay, that way we have just a little bit more room. The vertex is the center of the parabola. It is a point in the center of either a peak or a valley. So, say for example, here I'm going to scroll down to do this. If we have a parabola that looks like this, if we have a peak, that means it's something that opens down. The vertex is going to be right here. It's the center. Or if we have a valley, it's going to be a parabola that opens up. That means this is going to be the vertex here. It's the center of the parabola. Okay, so that is the vertex. Now we need to be able to say, okay, how do we find the vertex? The x-coordinate of the vertex is, let's still put a little bit more distance between that. Negative b over 2a. And the reason why this is the case, the reason why it's negative b over 2a, involves calculus. So I would have a hard time explaining it in this particular video. You're just going to have to take my word for it that the x-coordinate of the vertex is equal to negative b over 2a. So then, to find the y-coordinate of the vertex, plug the x-coordinate into the function. I'm going to have to put a line break in there somewhere. Oh, wait, there's another e in vertex. Okay, so to find the y-coordinate of the vertex, plug the x-coordinate into the function. So once we find this negative b over 2a, let's say that negative b over 2a equals 4. I mean, I have no idea what it is. This is just a random example. Let's say it turns out as 4. That means we would evaluate a times 4 squared plus b times 4 plus c, whatever that turns out to be. And then that will give us the y-coordinate of the vertex, because this equals y. Wow, that turned out to be bigger than I meant for it to be. Okay, so let's go ahead and hence I actually used the word hence. The vertex is negative b over 2a times, not times, so hence the oops, forgot another parentheses. Hence the vertex is, and this is a pair, this is a set of coordinates. So this will give us something like, once we evaluate negative b over 2a, that'll give us something like 4. And then f of negative b over 2a, that means we plug that back into the function, and it'll give us something like, I don't know, negative 3. Now, I hope you realize that I'm just making these numbers up. The point is that this is going to give you a pair of numbers. And this should look familiar too, because take a look at the concise info, and I'm going to scroll up and do just that, and we get the vertex is that. So this is just I'm explaining now how we get to that information. Okay, so put a little bit more room there. Hence the vertex is negative b over 2a, comma, f of negative b over 2a. So the y-intercept is the place where the parabola crosses the y-axis. I'm probably going to have to put a line break in there somewhere. Okay, the y-intercept, and I'm going to underline that. the y-intercept is the place where the parabola crosses the x-axis. This is where x equals 0. To find it, replace x with 0 and solve for y. Oh, and one more thing. There will be exactly one y-intercept. This is always going to be the case. There will be exactly one y-intercept. So that means if we have f of x equals ax squared plus bx plus c. To find the y-intercept, we replace the x with 0, so that means we have y, and solve for y. So we have y equals a 0 squared plus b times 0 plus c. Okay, so now I'm going to go ahead and show you something that's pretty obvious. When you replace x with 0, this term goes away, and this term goes away. So basically, the y-intercept is just going to be, the y value for the intercept will just be c. Now, the y-intercept will be 0, comma c. Now, the reason why I'm not putting this in the formal definition, more or less, is because there are going to be cases where if you have something other than a polynomial, then the y-intercept will not be c. It'll be something completely different because we're dealing with a completely different type of problem. But that's why I'm not putting that in the formal definition, more or less. Okay, so the x-intercepts, let's move on to the x-intercepts. The x-intercepts are the places where the parabola crosses the x-axis. Scroll down. The x-intercepts are the places where the parabola crosses the x-axis. This is where y equals 0. To find them, replace y with 0 and solve for x. So remember up before, we replace x with 0. Now to find the x-intercepts, we replace y with 0. So remember that you're replacing the opposite of what the intercept you're looking for. So if you're looking for the y-intercept, replace x with 0. If you're looking for the x-intercept, replace y with 0. Okay, so let's get back to the x-intercepts. So to find them, replace y with 0 and solve for x. So there's a few points to know about this. The x-intercepts are quite a bit more complicated than the y-intercepts. So remember the discriminant? If the discriminant is positive, there are 2 x-intercepts. Oh, crud, just a second. There are 2 x-intercepts. Maybe I can... There we go. That brings it closer together. So if the discriminant is positive, there are 2 x-intercepts. This should look familiar because this is the additional material, more or less, a supplemental material for section 9.2, I think. It might have been 9.4, but I think it was 9. Yeah, it was 9.2. Now, what this is saying is that if the discriminant is positive, that means we're going to have a solution a graph that looks something like this. That's all that's really saying. If, on the other hand, if the discriminant is 0, there is one x-intercept. That will technically not cross. So what that's saying is, like, let's say we have, and I'm going to draw a little bit. Oh no, I'm going to go ahead and scroll down. So if the discriminant is 0, there's one x-intercept that will technically not cross. What that's saying is that we'll have a parabola that, like, the vertex is on the is going to be on the actual x-axis. It doesn't actually cross because it touches it, then comes back up, but it still is technically considered to be an x-intercept. So that is how you'll get exactly. That's how you get exactly one x-intercept, and that's what it'll do when you have exactly one intercept. If the discriminant is negative, there are no x-intercepts. Okay, let's do another line break. So the reason why this is the case is because if the discriminant is negative, that means you're going to get a square root of a negative number. So you'll get a square root of like negative 16 or something. And what that means is you're going to have, let's do a little bit more straight than that. That means you're going to have a parabola that, like, opens up here or something like that. That's not a very well drawn parabola. That's still not quite right. Not even close to being quite right. So, or it's gonna open up down here or something like that. So this is a case where you don't have any x-intercepts, and so if you get a negative discriminant, and whenever you solve for x, remember that. Here, I scroll up a little bit. To find them, replace y with 0 and solve for x. That means you're going to be doing like 0 equals ax squared plus bx plus c. And so that means that you're going to get this type of solution. You're going to get this type of graph if your solutions for x are complex numbers, if they're non-real numbers. So we'll get some examples of that later. Let's go ahead, and now that we have this, let's go ahead and relate this back to the concise info. So here's the verbose information, the concise info. Remember that the vertex is going to be negative b over 2a for the x-coordinate, and evaluated that for the y-coordinate, and to find the y-intercept, set x equal to 0 and solve for y. For the x-intercept, set y equals 0 and solve for x. Okay, so I just want to go over that one more time. It was probably unnecessary, but I still thought it'd be good to go over. So let's go into an example. So let's say that we need to find the vertex y-intercept and x-intercepts and graph the function. Not vertex, vertex. Find the vertex, y-intercept, and x-intercepts and graph the function. And the function is f of x equals x squared minus 4x minus 5. F of x equals x squared minus 4x minus 5. So the first thing we want to do is deal with the vertex. And it's going to be the x. First thing I want to do is deal with the x coordinate. Let's do that on a new line. Okay, so the x-coordinate is going to be negative b over 2a. So negative b, remember that what we have here is ax squared plus bx plus c. So negative b, b is going to be negative 4. So negative 4 is going to be positive 4. And 2a, well, there's an understood 1 here, so a is an understood 1, or 2a, or so 2 times 1 will just give you 2. So that means that this is going to equal 2. Your x-coordinate for your vertex is going to equal 2. Okay, so now let's go on to the y-coordinate, and let's clear that off. The y-coordinate, we're going to evaluate this function at f of 2. So let's say this is going to be f of 2. All I did was I put 2 in for x here, and just like I put 2 in for x here, I'm going to put 2 in here and 2 in here. So f of 2 equals, and let's clear that off just so we can see it more easily, 2 squared. Let's go ahead and put that in parentheses. I often like to, whenever I'm putting something in for x, I often like to put it in parentheses. That way there's less room for mistake. So minus 4 times 2 minus 5. Okay, so 2 squared minus 4 times 2 minus 5. That's going to equal 4 minus 8 minus 5. Because 2 squared is 4. 2 squared is 4. Negative 4. Okay, let's create the negative for now because we still have the negative there. 4 times 2 is 8. And 5 stays the same. We haven't done anything to evaluate that. So, negative 4 minus 8, I'm sorry, not negative 4, positive 4 minus 8 will give you negative 4. Minus 5 equals negative 9. So, our x-coordinate is going to be 2, and our y-coordinate is going to be negative 9. Now, I want to point something out. What I've done here, I've done the work, but I have not written out an answer. I want to be crystal clear as to what my answer is. But what I've done so far, I have not yet given an answer. So, this is going to be my answer. The vertex is 2, negative 9. This right here is an answer. So I'm going to go ahead and put a box around it. The vertex is 2 times, not times, please forgive me for saying that. The vertex is 2 comma negative 9. So the point that I'm making here is there's a clearly marked answer. There's no room for misinterpretation. That's very good for you. It's very good for the person that's grading the paper. It makes life just a little bit easier to go ahead and make sure that the answer is perfectly clear. So that concludes the vertex. This is the vertex, 2, negative 9. Now let's go. The vertex is just the first part. Now let's go on to the y-intercept. So y-intercept. Y-intercept. Okay, so remember for the y-intercept, what we want to do, if it's the y-intercept, then we replace the x with 0. Or so that means we have that y equals 0 squared. Let's go ahead and put that in parentheses again. 0 squared minus 4 times 0, 0 squared, minus 4 times 0, 0 here, 0 here, and of course the minus 5. So minus 5. So you have 0 squared, it's just going to be 0, minus 4 times 0, it's going to be 0, equals 5. Negative 5, excuse me. I forgot to... There's a negative there that I accidentally passed over. So y-intercept is, for the y-coordinate, is going to be negative 5. But again, this is not a final answer. Just like before, I want to have a crystal clear final answer, and I will say the y-intercept is no star, didn't mean to put that there. 0, negative 5. And I like that answer so much, I'm going to box it up. The y-intercept is 0, negative 5. Okay, so the first question was vertex. We found the vertex. The second question was y-intercept. We found the y-intercept. Now we're looking for the x-intercepts. So let's go ahead and do the x-intercepts. Okay, so this is going to be, what I'm going to do is, I'm going to go ahead and rewrite this because I want to keep it available. When I rewrite it by hand, it doesn't scroll with everything else. That's why I'm rewriting it this way. So f of x equals x squared minus, ooh, that's not right, minus 4x minus 5. So f of x equals x squared minus 4x minus 5. So I just wrote that there because you can see that it doesn't scroll with everything else, so I can keep it there. So the x-intercepts, we remember for x-intercepts, for y-intercepts we replaced x with 0. Now for x-intercepts we're going to replace y with 0. So that means, for all intents and purposes, this is y. So we have 0 equals x squared minus 4x minus 5. So now we're solving a quadratic equation. We could go ahead, if we wanted to, and solve this by using the quadratic equation, but I'm going to go ahead and just because we're spending a long time on this, I'm going to rewrite this as x minus 5, x plus 1. So you can factor x squared minus 4x minus 5 into x minus 5 times x plus 1. Oh, I almost accidentally cleared all that off. Did not mean to do that. That would have been bad. Okay, so what I did here is I replaced the y with 0. We have y is 0 right here. And now we're solving for x. So we have x minus 5 equals 0, or x plus 1 equals 0. So that means that x equals 5, or x equals negative 1. So we have x equals 5 or x equals negative 1. That's the solution to this quadratic equation right here. But this is, again, not an answer. This one would definitely lose points because this is not a final answer. So let's go ahead and clear this off. The x-intercepts is going to have these for the x values, but there's still going to be two different x-intercepts. So the x-intercepts are 5, 0, and 1, 0. The x-intercepts are 5, 0, and negative 1. Where'd that negative go? Disappeared. 5, 0, and negative 1, 0. So, again, I'm going to go ahead and box that. That's the answer I want. The x-intercepts are 5, 0, and negative 1, 0. Okay, now I'm going to try to graph it. Now, I could go ahead and graph it on my computer and just show you the computer-generated image, but I want to go ahead and show you. I want to go ahead and draw it by hand, because that way you know how the process goes. It's not going to look too pretty because it's hard to draw this stuff. Oh, see, already I messed it up. It's hard to draw this stuff. So here is our y-axis. Here's our x-axis. The x-axis actually doesn't look too bad. So the vertex is at 2, negative 9. So it's at 1, 2. So this is x. This is x extended out to 2, negative 9. So that's going to go quite a ways down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, it's a good chance I did not space that out perfectly evenly because it's, like I said, it's really hard to draw this stuff. If it helps, you can draw some. You can invest in some graph paper. That might make things just a little bit easier. So the vertex is at 2, negative 9. So this point here is. I'm going to erase this in a second. I'll go ahead and write it 2, negative 9. So this is the vertex. So now, like I said, I'm going to go ahead and erase that now. The y-intercept, that's where it crosses the y-axis, is at 0, negative 5. So 0, it doesn't move left or right on the x-axis. 1, 2, 3, 4, 5. So that means we're going to have, we already know 2 points in our parabola. This point and this point. So now let's deal with the x-intercepts. So we need to go to 5, 0. So 1, 2, 3, 4, 5. So here's 1 point and negative 1, 0. Now we have a general idea of what a parabola looks like. It looks like it's a curvy thing. It looks like that. You know, something like that. So let's go ahead and try to connect the dots and draw a parabola that fits into these points. I just yanked the cord. I hope I'm still getting audio. Crud. Okay. Okay, I'm fine. I'm still alive. So let's go ahead and draw a parabola that goes through here. This is going to be a pretty skinny parabola, and up through here. You can see that drawing graphs is not exactly my forte. It's never been my favorite part of math. So let's see, like I said, it's not spaced out perfectly evenly, so it's a little bit lopsided. That happens. Try to draw it as clearly as you possibly can. Obviously, since I can't draw better than this, I'll have to accept it. So that will work for this. And this will be our final answer for this. This is the graph of the parabola. Oh, and also, you wouldn't lose any points for this, I don't think, but you really should put the arrows there, because that just indicates that it keeps going up forever and ever. So that is the graph for that parabola. We have 2 more examples after this, each one just a little bit different. I have no idea how long I've been sitting here, but this is going to be a long video. So let's go on to another example. Okay, so find the vertex space. Find the vertex, y-intercept, and x-intercepts, and graph the function of p of x equals 2x squared plus 4x plus 1. Don't let the p instead of the f throw you. It means exactly the same thing. It just means that we're using p to represent the function instead of f. It still means that y equals all this stuff, blah blah blah. So let's, first thing we want to do is we want to look at the vertex. So the vertex, let's take a look first at the x-coordinate. The x-coordinate is going to be negative b over 2a, so negative b is going to be negative 4, so negative 4 over 2 times a okay, so negative b over 2, so negative b over 2 times a, so negative b over 2a. That's going to equal just negative 1, because you have negative 4 on top, and then 2 times 2 equals 4 on the bottom, so that 4 divided by 4 is 1, so negative 1. So our x-coordinate is going to be negative 1. Our y-coordinate is going to be evaluating this at negative 1. So we'll have 2 times negative 1 squared plus 4 negative 1 plus 1. I got this by just putting negative 1 in for x. Negative 1 squared is going to give you just positive 1. So this is going to give you 2 for the first part, and then minus 4 plus 1. So 2 minus 4 will give you negative 3. Sorry, not negative 3, give you negative 2. Plus 1 will give you negative 1. So that means this is equal to negative 1. So our vertex, the vertex is negative 1 comma negative 1. The vertex is negative 1 comma negative 1. And I'm going to box our answer. The vertex is negative 1 comma negative 1. Okay, now let's go on to the y-intercept. Y-intercept. Oh, I don't want to lose everything. Okay, so I'm going to go ahead and write p of x here. P of x equals 2x squared plus 4x plus 1. Let's make it a little more clear. Plus 1. 2x squared plus 4x plus 1. Okay, so our y-intercept is going to be, we're going to replace x with 0 and solve for y. So we have that y equals 2 times 0 squared plus 4 times 0 plus 1. Okay, so just put 0 in for x. Just put 0 in for x, and this is going to disappear. This is going to disappear. You're only going to have 1 left. But again, this is not the final answer, because we need to write out the y-intercept is oops, I miswrote it. Okay, the y-intercept is 0, 1. And I'm so proud of that answer, I'm going to box it. Oh, and also a period. Didn't put a period up here either. Doesn't really matter if you put a period. It's just it's grammatically correct to put a period. Okay, so the vertex is -1, -1, and the y-intercept is 0, 1. So that is the y-intercept. Let's look for the x-intercept. So this is where this is going to turn into a kind of a different type of problem from the previous one. So okay, so now we're looking for the x-intercept. Remember, before, for y-intercept, we replaced x with 0, now we replace y with 0. So that means we have that 0 equals 2x squared plus 4x plus 1. Just replace this p of x, which is equal to y, with 0. Okay, so this one we can't solve by factoring, and that's what makes this one different. So we're going to have to solve it using the quadratic equation. I'm going to go ahead and do that now. So x equals negative b, which is going to be -4, plus or minus square root of b squared, which is going to be 16, minus 4 times a, which is 2, times c, which is 1. So negative b plus or minus the square root of b squared minus 4 times a times b, all over 2 times a. So remember, this is an example where we don't just have 2 times 1, it's going to be 2 times 2. So that is equal to -4 plus or minus, I wrote down -1 by mistake. -4 plus or minus the square root of 16 minus 8. So, because this 1 disappears and this 4 and 2 becomes 8. If it's all the same to you, I'm going to go ahead and rewrite that as 16 minus 8 is equal to 8. So 16 minus 8 is equal to 8. All over 4, of course, because 2 times 2 is equal to 4. So that means that this is going to be equal to -4 plus or minus square root, 2 times the square root of 2. Let's scroll to the right a little bit. -4 plus or minus 2 times the square root of 2 all over 4. Okay, so our x-intercept is going to be, let's go ahead and put that on a new line. I wonder if I can just do that without apparently not. Okay, so let's do this. There we go. So the x-intercept is going to be the x-coordinate for the x-intercept is going to be these two. Oh, this actually can be simplified a little bit further, because we can take a 2 out of each individual piece. Basically, let's rewrite this as 2 different fractions. No, let's not bother with that. For now, let's just go ahead and notice that we can take out a common factor for each of these. So just like how we have, let's do it this way. Let's factor a 2 out of this. So the greatest common factor of these 2 terms is 2. So just like how if we have x squared plus x is equal to x times x plus 1. I just took out the greatest common factor. I can do the same thing here. So this is going to be equal to 2 times negative 2 plus or minus square root of 2 all over 4. Oh, I forgot to put this next parentheses. So all I did was I pulled out the greatest common factor of 2. Because there's a 2 common to here, there's a 2 common to here. So now I have 2 on the outside. Now I can cancel this 2 with this 4. Cancel this 2, you'll get 1 left, which will become an understood 1. Cancel this 4, you'll get 2 left. So this is equal to negative 2 plus or minus square root of 2 all over 2. Let's go ahead and get rid of that stuff. So negative 2 plus or minus square root of 2 all over 2. You can see how a lot of this builds on itself. You know, everything, it seems like almost everything that we've done in this section we're doing here. So there's a lot of this stuff that just comes back and forth all the time. So our two x-intercepts, the x-intercepts are negative 2 plus or minus square root of 2 all over 2 comma 0. Whoa, sorry, not plus or minus. That's, well, you could probably put plus or minus and that would really be an acceptable answer, probably. But in this case, I'm going to go ahead and separate this out, make it a little bit easier to read. So the two x-intercepts are this part, and then I'm going to do the minus part as well. And oops. Okay, so negative 2 plus root 2 over 2 and negative 2 minus root 2 over 2. So these are the final answers for the x-intercept, and I'm going to box it. Okay, so now that we've figured out what the x-intercept is, we've figured out what the y-intercept is and what the vertex is, let's go ahead and plot this graph. So that's really messy. Okay, that's pretty straight. That's straight enough. So vertex is at negative 1, negative 1. So here's the vertex. The y-intercept is at 0, positive 1. Okay, I'm gonna make that a little bigger just because we can see it, so we can see it more easily. And let's scroll down. The x-intercepts are, okay, let's try and make this there. We can see them, everything now. So the x-intercepts, okay, what on earth is negative 2 plus root 2 over 2? Well, this is where we need a calculator. So I'm going to bring in my scientific calculator. Let's try to make this so that I can see the whole thing. This is just a very standard scientific calculator. This is obviously just a computer program, but if you have a scientific calculator, it should be able to do all the things that I'm about to do. It probably won't look exactly the same way, but it should still work. So I'm going to do negative 2 plus the square root of 2 all over 2. Please note, though, that on your scientific calculator, on this one, the negative sign works. This minus works for both negative and minus. On most scientific calculators, these will be separated into two different things. So you'll have one that has a minus and then one that has a negative, and those are not the same thing. In this case, they are, though. So when I evaluate that, sorry that this is still here. I don't want to erase it. So I didn't mean to do it like that. So that means that this part right here is going to be negative 0.29, and so that means negative 0.29 0, because this is our x value. So we'll write that here. So negative 0.29 0. And it's going to be a little harder to write that here, but let's do it. And that is being covered up. So negative 1.71. I'm rounding. Okay, now let's get that calculator out of the way. So these are our two x-intercepts. Now that they're in decimal form, we can more easily see where they go. So negative 0.29. Negative 0.29. Well, that's going to be a little less than a third of the way through. So that's going to be one here. That's a little closer to half, actually. So it's going to be about here. And then negative 1.71. Well, it's not going to be up to 2. It's going to be almost 3/4 of the way to 2, but not quite. So it's going to be somewhere around here. You can kind of see why this is not my favorite part of math. And now I'm connecting the dots. Except I didn't quite do it quite right. Didn't need to go through the dot. Okay, so then this is going to be the final answer and graph for this particular question. Alright, that was exhausting, but let's go on to one more example. This is the last example, and it's going to give us a different kind of solution. Let's go ahead and try it out. So, example, find just the same type of problem. Find the vertex, find the y-intercept, find the x-intercepts, and graph the function. And our function is going to be f of x equals negative 2x squared plus 3x minus 2. F of x equals, I got my cord tangled up again. I need to get a wireless or something. Okay, negative 2x squared minus plus 3x minus 2. And we're finding the vertex, finding the y-intercept, the x-intercepts, and graphing the function. Okay, so very first thing, the vertex. For the vertex, we will do negative b over 2a. Okay, sorry, I got lost on something. Is going to be negative b. Okay, so negative b is going to be negative 3. So negative 3 over 2a, so 2 times negative 2. Instead of doing a dot, let's just put that in parentheses. So negative b over 2a. So we're going to have a minus times over a minus, so those minuses are going to become plus. And that is going to be equal to 3/4. Okay, so 3/4 is going to be the x-coordinate for the vertex. So let's go on to evaluating f of 3/4. So f of 3/4, just like before, f of 3/4 so that's going to be -2 times 3/4 -2 times 3/4 squared plus 3 times 3/4 minus 2. Okay, so we have -2. Let's make sure I double check this, make sure it tries. -2 times 3/4 squared plus 3 times 3/4 minus 2. That's right. Okay. So let's go ahead and clear off the scribblings. So this is going to be the same thing as -2 times 9/16. Yeah, it's going to be 16ths. -2 times 9/16 plus 9/4 minus 2. Okay, so that is going to be, I wonder if I have enough room to keep going on this line. So that's going to be -18/16, -18/16 plus 9/4 minus 2. And that -18/16 can be reduced. So -18/16 will give you -9/8 plus 9/4 minus 2. -9/8 plus 9/4 minus 2. Now I want to go ahead and, if it's all the same to you, I'm just going to rewrite this as 18/8. I just doubled top and bottom. That way I could combine these more easily. And I'm going to rewrite this 2 as 16/8. That way it saves space. So -9 plus 18, that's going to give us +9, minus 16, that'll give you -7. So you'll get -7/8. So this is the, there's 2 colons there, I just now noticed that. That is going to give us this is the x coordinate, this is the y coordinate. So that means the vertex is 3/4 -9/8. Oh, close parentheses. 3/4 -9/8. You can already kind of see that this is going to be a little bit difficult to graph, because it's kind of hard to graph things that have fractions in them like this. So that is the vertex. The first, I'm sorry, not the only vertex. The first thing that we had to figure out. So the next part is the y-intercept. So part 1, the vertex is done. Let's go on to y-intercept, and let's go ahead and I'm going to rewrite this just so that we always have it available. F of x equals -2 x squared. Let's rewrite that. Squared plus 3x minus 2. Okay, so now we're going to have that available as long as I don't accidentally clear it. So, xintercept, we want to replace the x with 0. So that means we're going to have negative 2 times 0 squared plus 3 times 0 minus 2. And of course, oh, I should say that y equals. So that means that we're going to have we already know that our x is going to be 0, but our y is going to equal, cross that out because you're multiplying by 0, so that's going to be equals minus 2. So the y-intercept is 0, negative 2. And just like before, I'm going to box it. The y-intercept is 0, negative 2. Okay, so I'm going to erase this, but I'm not going to clear it because I want to keep this over here. Now let's go on to the xintercepts. So with the xintercepts, we replace the y with 0 and solve for x. So that means we have 0 equals negative 2x squared plus 3x minus 2. So let's go ahead and put this into the quadratic equation. So we're going to have x equals negative b. Negative b is going to give us negative 3 plus or minus the square root of b squared is going to give us 9 minus 4 times a times c all over 2 times a. Okay, so notice something. We have 3 negative signs here. So that means we can cancel 2 of them. That does not mean we can cancel all of them, because you can only 2 negative signs will cancel each other out. 3's will give you just another negative sign back. So that means we have 9 minus 4 times 2 times 2. 2 times 2 is going to give you 4 again. 4 times 4 will give you 16. So that means that this is going to be equal to negative 3 plus or minus the square root of 9 minus 16 all over negative 4. 2 times negative 2 is negative 4. Now I'm going to go ahead and rewrite this minus 16. 9 minus 16. Just because I don't want to go to the trouble of rewriting that entire thing. That's going to be minus 7. And now we have an imaginary number. Because this is going to give us, you can't take the square root of negative 7 and still get a real number back. So that means that there are no y-intercepts. Let's go ahead and erase that. So the answer to the x-intercept part is there are no x-intercepts. And let's box it. So how do we graph this without x-intercepts? Well, the y-intercept helps, and that's probably all we need, really. But all we really need is 2 points on either side of the vertex. So let's go ahead and let's scroll down and get started. Well, the vertex is going to be at... Oh, that's bad. Let's go ahead and try to draw this as best I can. The vertex is going to be at 3/4 negative 9/8. Is that supposed to, oh, I mistyped that. That should be negative 7/8. It's negative 7/8 here. It needs to be negative 7/8 here. Okay, let's figure out where that is. The vertex is negative 7/8. There we go. So we can erase that now. Okay, so I'm going to more or less make my tick marks really big, because that way I can see pretty clearly what I'm going to be doing. So 3/4, because I'm dealing with inside the tick marks, so it'd be kind of annoying. So 3/4 is going to be, say this is halfway. This is going to be 1/4. This is going to be 2/4. This is going to be 3/4. So this is going to be the place we're looking for. Negative 7/8. That's even harder, but it's going to be the same basic principle. So negative, so halfway, halfway of halfway, and then halfway of halfway of halfway. Basically, for something like this, the best you can do is get as close as you can. As long as you get pretty much, as long as it's clear that you're trying to get it as precise as you can, that's all that really matters. If you don't get it exact, obviously, there's not much that can be done about it. So, this is the vertex. The y-intercept is on the y-axis, of course. So y, it's going to be, remember this point is 1. Don't forget that this point is 1. So that means this is, I'm sorry, I should say negative 1. So that this is negative 2. So at 0, negative 2, this crosses the line. So all we really need is 2 points on either side of the vertex. So we have 1 point on one side of the vertex, and let's go ahead and get another one. So let's go ahead and scroll down. Now I have more room, so I could say that it doesn't need to actually be crossing anything. I could just say try x equals 2. All I'm doing is I'm going to find out where is this function going to be when x equals 2. So here's 1, so that means here's 2. So that means that I'm going to figure out where along this line, more or less, is the point going to be. So if x equals 2, then we have negative 2 times 2 squared plus 3, 2 minus 2. This part right here is going to give us negative 8. That's a weird looking 8. This part here is going to give us 6. Negative 8 plus 6. This part right here is going to give us minus 2. There's no further evaluating that. This is going to be minus 4. So that means that at x equals 2, we're going to be all the way down at minus 4. So we're going to have to extend this quite a bit. So that's 1, 2, 3, 4. Obviously, notice that this is not, it's kind of lopsided. It's not really, well, you'll see. So the reason, when I say it's lopsided, what I mean is that it's not, the points that I picked on either side of the vertex are not equidistant from the vertex itself. All I need is something to connect the dots, pretty much. So here are the 3 points, and here is the parabola that I have drawn. Okay, this has been a very long, and I'm sure just as tedious for you as it was for me. That concludes section 9.5. I will see you in the next video.